Don't you ever just make a YouTube video, watch through it, and then realize, I could have phrased a few things better in that video. That's what I really thought about my last video, which is JavaScript for hackers. And in this video, I want to explain some of the small inaccuracies I think I made in that video, or just kind of bad explanations that I think could be rectified a little bit, just to give you a better understanding of the complexities around JavaScript and client-side vulnerabilities in general. If you haven't seen that video, then I highly recommend you go see it before watching this video. And also, if you don't really understand JavaScript that much, particularly if you're still a beginner to reading JavaScript, then this video might not be for you, as it's going to cover some of the more complicated aspects of JavaScript. One thing you might notice is that JavaScript doesn't have types. It's not a typed language by default. We have either constant, so const is something that you can't change, so once I define it, it's not changeable. Or you can have like a let. There's the two main ones. Like a let is something that we can't change, it's like a variable. You can also have var, which is the one. I never use that though, I just use those two. This wasn't as much of a mistake as just kind of a bad explanation of what JavaScript variables actually are, particularly of this variable var. Var was actually the first JavaScript variable, so pre-2016, this was the only JavaScript variable there was. And what you would do is you would just declare the variable to be, say, like a string, say hello, and then you could change it whenever you wanted to. So it was just like a normal variable in any programming language. There was no type on it, so you could make it anything. You could make it a string, then change it to an integer, then change it to a boolean. So you could do whatever you wanted in that sense. And you could change it, so it was a changeable variable. And that was the only variable you could use until 2016, when they added two new variables, which were let, so let is here, and then they also added const, which I'll get to in a minute. Var is still, you can still use it, by the way. There's nothing wrong with using var anymore. It's just not used that often because the other two have a few advantages. The thing about var is that, unlike the other variables, you can actually redeclare it. So you can declare it again. This is completely valid. You can run this and it'll still run. Maybe I'll even show you too. You can run it and everything will still work. And you can actually access it before you declare it, which is another unique feature of var. So if you go here, I can go inspect, and in the console you'll see undefined. It's undefined because I only actually give it a value here. So if I go here, I go console.log test here, and I refresh the page, you'll see 1, 2, 3. The reason we can access it before we actually declare it is because by default in JavaScript, the var variable gets hoisted up into here, and it is declared as an undefined variable. So all of the vars get kind of taken up to the very top, and they get declared like this with an undefined parameter. So that's the unique things about var. One of the other things that we know about var is that if we have a function, like say, test, for example, we can declare a variable inside of that function, and we shouldn't be able to use it outside of the function, like this. We should not be able to, maybe we'll do something different. We shouldn't be able to use it outside of the function like this. So if I refresh the page, you'll get the function test. Sorry to say that too. And yeah, we shouldn't be able to use it outside of the function because we've declared this as a local variable. So in this case, if we declare two vars like this, like 1, 2, 3, 1, 2, 3, 4, we have them called the same thing. If you reach that page now, it'll print out the one that's globally declared, so not inside of this function. This doesn't apply to code blocks though. So what is a code block? It's, for example, like an if statement, right? So if we have an if statement like this, and I say true, so I'm in the same now always run, and I, for example, go here, I declare a variable called test again, and I call it 1, 2, and I do console.log test, and then I run it again. I'm going to get rid of this one so it's just not confusing. I run it again. Sorry, I never actually called the function. I say test2 here. We'll try and run the function like that, and you'll see 1, 2 is printed out and not 1, 2, 3, which means that inside this if statement, inside this code block, the var kind of carried through, right? So the new variable that we've declared is like the new one, right? which can get a little bit confusing for some people. And this was the major reason why they actually changed var, was to change this behavior and make it so that this var here was actually a different variable to this one here. And they changed that by introducing the function, the variable let. So let is pretty much the same as var, except that you cannot declare it again like you just saw. You cannot redeclare a let variable. So once you use it once, you can't redeclare it again. And then if we use like the same variable here, so we have, if we declare like a let, like let's test here, and I get rid of it here, this, for what I know, shouldn't work. So if I go here, yeah, it shouldn't work. So this is scoped to a block, while the var variable is just scoped to a function. So we cannot use it outside of this code block. And this applies to like for loops and while loops, and really anything that inside these curly brackets is considered a block. That's the main really difference between let and test. Let and var is that var is scoped inside functions and let is scoped inside code blocks. Another thing is that let doesn't have any hoisting. There's nothing. We can't use it before we declare it, is what I mean. So if I go console.log test here, I try and use it before we've actually declared it, I'll just get an error because it's not defined, right? So we can't do that with let, which is generally good. You generally want to have this kind of safer behavior. You don't really want to be able to use variables because before they're declared anyway. That just seems like it's going to lead you into kind of traps where you have broken code and you don't know why. So it's good that they changed this, and it's the reason why let just tends to be the more used variable now instead of var. Var is really seldom seen now just because these two variables kind of came in. The other one is called const. Well, const is, as the name implies, it's constant, so you can't change them. So once you declare a const, you can't just come in and say 1, 2, 3, 4, because then we will get an error. So invalid assignment to constant value. The thing that you can do though is if we have a constant and it's an object, so we go here and we declare it as a JavaScript object with, say, a value set to 1, 2, 3, 4. What we can do is say test.value is equal to 1, 2, 3, 4, 5. And that's completely fine. We can still print that out, and JavaScript is fine with that. Which means that if you have an object with specific values inside of it, then you can change the values inside of it without an issue. What you obviously can't do is come in here and redeclare the object. So you can't do that. You can't change the object, but you can change the values inside the object, which is actually why constants, I think, are the most used JavaScript variable out of all of them. It seems like a bit of a contradiction because a constant isn't a variable, is something that we already know. But because we can change the values in the object and most types and data are stored as objects, then that means that we can use this constant a lot, and it just prevents mistakes as well with people reassigning objects and stuff like that. Just like the other variable, we can't redeclare constants, and it's, I think, scoped to blocks as well, as far as I know. We can maybe test it as well right now. It should also be scoped to blocks like let. So if we do something like this, see if we declare here, it also shouldn't print out test, to my knowledge. Yeah, also should show it's also scoped to blocks just like let is. So the main differences between all the JavaScript variables, there's 3. So pre-2016 there was only var, and then they introduced let and const in order to just rectify a few issues to do with basically var being scoped differently and being scoped to functions rather than being scoped to code blocks. And yeah, that would become the most used variables. So if you need a variable which is an object, you generally will use a constant. If you need like a small variable which is going to be a simple value, like a string or a boolean that you're going to need to change in the future, then you will generally use a let for that. And yeah, those are the 2 JavaScript variables. So hopefully now you have a better understanding of that. Basically happen. It's unlikely that this would be like a prompt, even though this is not used, but this is actually not exploitable anyway because we'd have to get the user to type this in, which is unlikely. What it will usually be is like, for example, it'll take like window.location, and then it will get like the last one, right? So it'll say like path name, and then it'll get like the last path name basically using the string. what it will usually be is like when you have like an ID parameter, it'll have like 1, 2, 3, 4, 5. It'll take that and then put it into a different API endpoint. Right, this isn't as much of a mistake as there's kind of a weird use of this prompt function to demonstrate client-side path traversal, which is normally URL based, so normally appear up here. One thing that I did mention is that you actually need the value from the URL to be URL decoded before you can actually inject it into any fetch parameters. The good thing is that most JavaScript functions and like properties will URL decode stuff for you automatically, which is kind of nice. So if I say here, I'm going to say new URL search parameters. Search parameters are just going to be the query parameters up here in the URL. I will want to say something like window.location.search. Then I'm say just going to get a parameter called ID, for example. There you go. That's going to become my ID. If I save that and I just go up here and I go ID will say 1, 2, 3, and I say fetch this URL, you can see 1, 2, 3 is appearing in the URL, which is nice. It's making a request to example.com. If I do something like put down, say this thing like 22 URL encoded, go here, let me say fetch URL. You can see it's been URL decoded for us automatically, so it's making the request there. And the same thing will go for these slashes, right? So these slashes, same thing will happen. There will be URL decoded and treated as actual slashes because the new URL search parameters function and this window.location.search will decode stuff for us automatically, which is cool. That is very nice. So now we can do something like this here, // here. Then when we fetch the URL, you can see we can traverse back the path, which is pretty nice. That's basically going to allow us to traverse back the path. That's one of the ways you can get it. I have this little ChatGPT function here, which is going to take the path name, and this is another one which is vulnerable to decoding. It's going to decode stuff in the path for us automatically. We're going to say get ID from path here, and in this case, I'm just going to it's going to take this main.html one just because I'm using a file for it. It's going to be a bit weird. We'll see if it works though. I want to refresh the page. Stop that. To refresh the page, I'm going to fetch the URL. You can see main.html is there. If I put like this, like a slash here, and then fetch as well, you can see that it's also been decoded. So if I put down like a .. slash here, it's not going to work because it's a file. But if I was on the website, I could put down .. slash, and it would go back the path. Phenomenal. That's why you kind of want to sanitize stuff when you're using this. So when you're using window.location.pathname, you probably want to have that sanitized. You want to get rid of it, right? One thing you can do to actually prevent client-side path traversals is by basically encoding the variable into the path, right? So what this will do is this will URL encode the variable again, so that basically there will be no traversal here anymore. So if I go back to using these URL search parameters, like though, I'll just write it again. Let's say URL search parameters window.location.search, and then we just get the ID parameter again. So if I do that, and then I have this actual URL encoded, when I go to say like ID, I go to like traverse the path. We'll try and get a path traversal here. So we're gonna fetch the URL, and this time you can see that it's been actually URL encoded. So although you can see the .. slash there, it's not actually like a .. slash, because if you see at the post, it's a URL encoded, so it's actually treated as %2f, which means that there will be no client-side path traversal there. And if you see something like that, if you have like a .. slash typed in and you see %2f instead of a actual .. slash, it's not been normalized. That means that there's most likely no client-side path traversal there to look for because the URL is being encoded like so. And this will effectively prevent us from having any client-side path traversal vulnerabilities. One other thing is that a few of the JavaScript variables don't actually URL decode the output. So one of them is window.location.ref, which will give us back a raw string. if I go console.log ID here, if I say that and I say refresh it now, I'm going to go to my console and I'm going to fetch URL. You can see that it's actually been it's been treated as a raw string. So we have %2f there. We don't have a slash. So if the website is using this to basically fetch IDs or fetch like stuff from the URL, that means that it will not be URL decoded, so it'll be straight raw, and then there will not be a client-side patch reversal there either, unless they go in and actually decode it themselves. So unless they basically do the opposite of this, which is decode URI component, unless they do that, there will be no client-side patch reversal. So that's something to look for when it comes to client-side patch reversals, is URL encodings. It's actually very important. If you're using a JavaScript type that is URL decoding the variable and then they're not sanitizing it, and then they're putting it into a URL like this, that means it could be vulnerable to client-side patch reversal. If they're using a non-vulnerable element, like this ref element here, and they're not URL decoding it, or they're basically preemptively encoding the data type in order to basically prevent client-side patch reversals, then it's likely not vulnerable to client-side patch reversals. Bit of an issue here though, and there's a few security concerns that come with post messages. See, anyone can open an iframe, right? So I can iframe this widget myself if I wanted to. Right, so any website can iframe any other website. Well, is this true? Let's say I have found an amazing post-message cross-site scripting vulnerability on Stripe, and I'm going to try and exploit it. So Yaksec told me that now I have to iframe the website, and then send a post message to the iframe. That's cool. I'm going to go here, I'm going to type in iframe source, HTTPS, I'm going to go to dashboard.stripe.com, and then we're just going to close the tag and refresh the page. Oh, what's happened here? Why can't Firefox open this page? Dashboard.stripe.com will not allow Firefox to display the page if another site has embedded it. Well, what's going on here? So unfortunately, or maybe fortunately, depending on what kind of angle you want to take on it, there is now a actual special header option to disable websites from being able to iframe your website. And it's a HTTP header, so it's present in the response of the website. And if this header is present, so either one of those, then Firefox or any other browser will prevent the website from being iframed by another website. And this is something that came about to prevent a vulnerability called clickjacking. So clickjacking was an old vulnerability, and basically what you could do is you could place an iframe, you could make it invisible, and have the user like press on the website thinking that they're just like, they're just on a website. But behind the actual iframe, the iframe was active and the user was actually performing actions on behalf of their account while just navigating your website, right? This was something that you could do to kind of get around like same origin policy and basically like kind of, like try and get like people to do things that they weren't supposed to do. For example, one of the funny things you could do is if you iframe the Facebook post, you could make the user press the like button and you could like farm likes on your Facebook post by iframing it, which is a pretty funny vulnerability. There was other things you could do, like for example, if you could iframe someone's like settings page on their account, you could like get them to like press the delete account button and then confirm it, which is why nowadays most websites have like a confirmation email to delete your account. Like back then you could just go and you could click delete and your account would be gone. Now it's like you have to go to like 7 confirmations to make sure that no one has a clickjacking vulnerability on you, which is the main reason that these things actually exist. And this is kind of brought in to prevent this. So there's 2 options here. You can deny iframes in total. You can just have no website be able to iframe your website. Or the more common option, which I think is standard in servers like Apache and Nginx, which is you can have websites that have the same origin as you iframe a website. So for example, if there was stripe.com, right? You had stripe.com. If I wanted to iframe this, I would have to have a .stripe domain. So I would be able to iframe it from like app.stripe.com, for example. I could iframe it from a website like that. Apart from that, all other websites are denied. Okay, well, does this mean that we can't execute post-message cross-site scripting anymore? Does that mean that if we find a post-message cross-site scripting, that if there's this header, that we just can't exploit it? Well, not exactly. Post-message isn't just for communicating between iframes. it's communicating between windows in general. And that's generally what it serves for. And we can open a window in many ways. We can obviously use an iframe to open a window, but we can also use this function, which is called window.open. And what this will do is it'll actually just open a new tab in our browser with the window. But we can actually still use a post message further. So if I go to open the same thing, I'll just open the widget like so. I'll go to script. What we can do is, instead of basically having the talking to the post message, talking to iframe, we can just talk to the window in the same way. So we can just do window.post message like so, and then we can send the message out. Maybe I'll actually bring that back. Yeah, we'll just bring this back here, and basically we can just do frame.post message and the exact same contents right here. So if we do that and I refresh my page, it might not work because we might have to wait a few seconds for the window to load. So I'll just go set timeout. I'll create this function here inside of it like so. Then I'll paste our stuff in here, and then I'll have it wait about, we'll say, 2 seconds for it to work. So we'll go here, we'll close the browser there, and we'll refresh the page, open it 1, 2, and then you can see our alert has popped. So if we go here, okay, it didn't log it on the thing because it's not an iframe, but the XSS worked. It was still, the cross-site scripting worked completely fine. That means that if we have a post message vulnerability, then instead of just basically iframing it, which we can also do if the header is not there, we can just open a new window with the actual URL, and then we can just send a post message to them. So that doesn't mean that that doesn't mean that post message cross-site scripting vulnerability is unexploitable. It actually doesn't affect it at all. What it does prevent is clickjacking vulnerabilities, which is the main reason it was developed. However, post message is still definitely exploitable, even if these headers exist. Also, no pressure, but if you enjoy some of the labs that I make and you think you get good value from them, then you can visit the link in the description, which will take you to some of my practical labs that I host online. There are 12 practical labs, which are all just hosted on a website, so you don't need to download anything, you don't need to set anything up on your computer. You just press a button, you follow a link, and then you just basically do them in your browser, just like the web hacking vulnerability should look like on a normal website. I think they're very good labs to learn from. I've modeled them based on vulnerabilities that I have found and that other hackers have found, which I thought were particularly useful and particularly easy to miss on these programs as well, which have made me a decent bit of money in the future. So if you're interested in that, follow the link in the description and that will tell you more about it. I hope these corrections enlighten you to some of the complexities of client-side JavaScript, and I hope you see that it's a very constantly changing playing field. A lot of things changing. You can see like these headers are being added, these variables are being brought in, this feature is changing. There's a lot of stuff going around, which is good because ultimately moving us towards a safer internet. As a hacker though, you do need to keep up with a lot of this stuff. You need to read about these headers, and yeah, some people can make mistakes like I did, saying that you can iframe any website, but in general there's like a header brought in to prevent that. So you do need to keep track. You need to read like the Chrome release logs and stuff like that in order to keep your client-side game sharp. Also, Merry Christmas if you celebrate it on the 24th. I think it's a real day anyway. Also, it's a good time to reflect on some of the progress they have made in bug bounty over the years. Since the year is coming to a close, and even if you find a vulnerability, you probably won't be able to get rewarded until next year. So it's a good time to basically reflect on the stuff that's been working for you, maybe things that haven't, things you can work on, improve on, and just the general progress you've been making since the start of the year. If you have any feedback or any suggestions on things I should make videos on, then please leave them in the description below. I think I'll probably release at least a few more videos before the end of the year, so I should get a couple of suggestions in before New Year's Eve and stuff like that, so you can leave them in the comments below. And yeah, that's it for me. Thanks for watching and happy hunting.